In this video, I'm going to go over the very basic stuff of how to name a compound, determining the type of compound, and then doing the individual ions for the ionic compounds and acids. The first thing that you need to know how to do is determining what type of compound it is. If you have a metal for your first element, it's an ionic compound, and you're going to follow the ionic naming rules. If your first element is a non-metal, then it's a molecular compound, meaning it forms covalent bonds, not ionic, so it does not have individual ions, and then you follow the molecular naming rules. If hydrogen is first, then it's an acid, and you follow the acid naming rules. Okay, how do you know where metals and nonmetals are? Look at your periodic table. This stair-step line separates your metals and nonmetals. All of these are metals. If they're up here on the top to the right of the stair-step, they're nonmetals. Okay, and then hydrogen means they're an acid. So these are all ionic compounds. These will form molecular compounds, and then hydrogen is an acid. Okay, so let's look at a couple examples. These are the ones that I'm gonna do in this video. So CaCl2. Calcium is first. Calcium is here on the periodic table, which is a metal. So this is an ionic compound. To get the individual ions, put your first element, so Ca, and then you put whatever is left, okay, without the subscripts. If it's just, if it's not a polyatomic, you don't put the subscripts. So this is just chlorine, so I put chlorine here. Okay, the ions that forms are calcium and chlorine. Then you can look at your periodic table and get the charges. Okay, that's why we have them written up here. So Ca gets a +2 charge. Cl has a -1 charge. Okay, and I'll do examples where you don't know the charges just by looking at the periodic table, but for this one, we know the charges. For ionic naming, the first thing that you do is name your metal. The metal is calcium. If it is not a transition metal, it does not get Roman numerals. Okay, calcium is not a transition metal. These in this middle section are transition metals that get Roman numerals, and our two exceptions, tin and lead, also get Roman numerals. Okay, but calcium is over here, so it does not get Roman numerals. Then I just named the second part of this. This is a chlorine. So if it's just one element, not one of these that's down here, okay, you change it to an IDE ending. So instead of chlorine, it becomes chloride. Okay, if it doesn't already have a special name, you change the ending to IDE. Now, the next one, NO2. Nitrogen is N. That's on the right of this stair-step line, so that's a non-metal. And if your non-metal is first, that means this is molecular, which also means that it forms covalent bonds, so it does not have individual ions. Okay, these are covalently bonded, not ionically, so they don't have ions. To name it for molecular, that's when you use your Greek prefixes. Okay, mono, di, tri, tetra, penta, and so on. Your Greek prefix comes from how many you have of that element. So for nitrogen, the first element, I only have one of them. There's no subscript here, so it's understood that there's one. You can say mono nitrogen or just nitrogen. If it's anything besides mono, you have to put the Greek prefix. Mono is the only one that you have the option of not putting it. Then do your second one, same thing. Greek prefix from the subscript, the beginning of your element name, and then change it to IDE. Okay, so for the first one, it's just the Greek prefix and the name of the element. The second one, it's the Greek prefix. 2 is di. The beginning of the element name, this is oxygen, so ox, and then it ends in IDE, so dioxide. That's the name for that one. Our next example is TiCl3. Ti is titanium, and that is a transition metal. Okay, it's a metal, so it's ionic, but I also know that since it's a transition metal, I cannot look and find the charge from the periodic table, and I need Roman numerals when I'm naming it. So ionic, put your first element, and then put what's left. Ti and Cl. Okay, like I said, I can't just look at the periodic table and get the charge for this one. So first I need to use this chlorine. Okay, your negative ion, your anion, you'll always be able to find either on your periodic table up here, or it'll be one of these special ones that's written down here. Your chlorine is here, gets a -1 charge. Okay, here's the trick with this. You would think this would be +1 to balance. However, you need to keep your subscripts in mind. The charge on this chlorine is -1, and I have 3 of them, which means that if I have 3 -1s, that's -3. So to balance that out, I have to have +3 for my titanium. Okay, I'm going to explain that one more time. Your charge on your chlorine is -1. Okay, I got that from the periodic table. If I have a charge of -1 and I have 3 of them, that's -3 overall. So in order to balance that out, this has to be +3. So when I name it, this is titanium. Then I have to put the charge in Roman numerals in parentheses because this is a transition metal. So the charge was +3, so I put 3 in Roman numerals. Then name the second part of this. Just like before, it's chloride. Okay, this next one has hydrogen first, which means it's an acid. Okay, acids have individual ions, so you would have H plus. It's always going to be H plus for an acid. It doesn't matter how many you have, it's H plus. Then you do what's left, so that would be SO4. Okay, I need to keep that SO4, I need to keep the 4 here because it's a polyatomic. If this was in parentheses with another number on the outside, then I would not keep that. But this SO4 is functioning as an ion. It's a polyatomic ion. Okay, that's one thing, this whole SO4. You can either look up the charge on your periodic table, wherever you wrote your polyatomic ions, or know that this subscript here after the H is what your negative charge is here. Okay, so you can either see the 2 here and make that -2, or you can look on your polyatomic list and see that SO4 has a -2 charge. Okay, when you're naming these acids, it depends on what your ending for your anion is. This is a sulfate. Okay, how did I know that? Again, it's right here. SO4 sulfate. This ATE ending changes to IC. Okay, also sulfur is one of those exceptions. Sulf changes to sulfur. So it would be sulfur and then IC, acid. So sulfuric acid. You don't name the hydrogen or anything like that. It's understood that there's an H plus here because it's an acid, and acids release hydrogen ions in water. Okay, the next one is Li2CrO4. Li is lithium, which is on the left. So that's a metal, which means this is ionic. Metals are ionic, nonmetals are molecular, hydrogen is an acid. For the individual ions, name your first element, Li, and then whatever is left, CrO4. Okay, this is an easy one where the charges are just on the periodic table. Li has a +1. And then you find chromate. CrO4 has a -2. So plus and -2. Then you name it. The first element gets named. This is not a transition metal, so it doesn't need the Roman numeral with the charges. And then you name this part. CrO4 is chromate. That's it for that one. Okay, the last one has hydrogen first, so this is an acid. Acids start off with H+, and then Br. Okay, remember, whatever this subscript is, that's your negative charge. Or, if you'd rather look on the periodic table, you can do that too. Br has a -1 charge. If I were naming just this ion, okay, which I have to do because that will tell me how to name the acid. This is a bromide, okay? The element is bromine, but you change the ending to IDE. Okay, this has an IDE ending. For those, they change to the hydroic acid. Okay, this one was acid too. I just didn't write that. So I keep this brom and put it here. So hydrobromic acid. If you're confused about the acid naming, you can look up the rules. They're on the recap that I posted on Monday, and they're in the original packet that you have as well.